Hi everyone. In this video we are going to understand importance of integration and why we need to study integration and how do we apply integration in physics. Okay? So yes, integration. So what idea do you all have of integration actually? Right? So I will come with a scenario first. Like suppose there is a rod. This rod has a charge of lambda suppose which is coulomb per meter. Charge per length is equal to lambda and there is a charge here q. Okay, now we know that whenever there are two charges, like suppose there is a charge positive q and there is a charge negative q, like whenever there are two positive and negative there will be some attraction between them, right? If there is a plus plus there will be they will repel each other, right? This everyone knows. So yeah, so what will happen in this case is, if you see charge, this is charge per meter. So if you see there will be a small charge here q, dq is, you consider that dq is a small element, dq is a small element of q. So what will happen here, this will have some force between this and this, right? Then there will be one more element dq here which will have some force between this and this. And what will happen, because the length is different, this is suppose a, this length is a plus dl, then this length will be a plus suppose 2 dl, right? So as per the length increases, the attraction or the repulsion force between them will go down, right? It is a function of length. Now there are two types of people who can do it. There will be one person, what he will say, okay, I will take this rod, I will break it into very minor pieces. Like suppose there is a person, he will say, I will break it into 500 pieces. Okay, and what he will do, he will use the formula and find the force of attraction of this element, this element, this element, this element. He will spend an entire day, find for each of the elements, add it, that will be his final force. Okay, this will have some accuracy of 50%. Then there will be a one more guy, he will say, okay, you broke it into 500 pieces, I will break into 1000 pieces suppose. Okay, if I break them into 1000 pieces, I find out the force, it will have an accuracy of 60%, right? Then there will be a one more smart guy, he will say, I will use an entire month, I will break it into 1 lakh pieces and I will find it, this guy will have an accuracy of 90% suppose. Okay, but this is not the ideal way of doing it. A person cannot solve one problem for a month, right? So maths comes to save here. Okay, so integration is actually a lovely phenomenon which joins maths with physics. So maths comes up with a snake here, this is known as integration. So what this snake does is, this snake breaks the element into many minor pieces. You can think of it as an infinity number of pieces, and it adds the effect of each of the pieces. This is what this symbol does. That makes our physics simple, right? So now the same problem, how will I solve, right? I will say that, okay, let's consider this as an element. So now we know that there is lambda, which is already told to us. It is what, it is charge per unit length, right? Then what do, we take this rod, we take a small element known as dq here, because this will be a small element, it will have a charge dq. We know that there is a q here and there is a distance of a, right? So what do we do here? And this is at a distance of dx from this end. This is of a length dx here. This is of a length dx. So what will happen here? For the lambda for this is dq by dx, right? So what will the formula be for this element? It will be integration of a to a plus l by l, because this is of entire length l, right? A plus l. K is a formula which comes a part of the formula constant. Q times. Now this is the dq, right? We have to find the force of calculation. So what is dq? dq is equal to lambda times dx. So this is lambda dx by x square. What is x actually? X is a variable, so this dx is a part of x. So what will happen? It will take each of the x's like dx, 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 dx and add it from a to a plus l. So this is what our integration will do. So what our integration will do is, it will start from here a, it will break it into many small dx's, take it from a to a plus l. Got it? And we'll have the answer to our problem. Now suppose there are many types of problem, like if there is a rod, okay, we know how to solve integration for a rod. Now we break it into a small element dx. If there is a mass, it has a mass of dm. If there is a charge, it has a charge of dq, and we just integrate it over the limit. Like from, if I want to travel x from here to here, I will name it as from 0 to l, suppose, then I will integrate it from 0 to l. It depends from the problem statement, like how do you want to define the limit. But basically wherever from x you want to travel, that is our limit. Okay, x is a variable here. So this is how we solve for a rod. If suppose there is a ring, okay, if suppose there is a ring here, so how do I take a ring? I take a ring like this. Right? If suppose there is a ring here, what will I do for a ring? How do I take so problem with integration in physics is you have to identify the element. If you are able to identify the element, you are able to do it. So what will be here? Here it is dq is equal to lambda times dx, right? So whatever is the small charge here, it will be lambda of that times dx, because lambda is charge per unit length, right? Here what it will be? Here I need to take a small element here. So how will I take this element here? So I know the radius is r of this, right? So what I will do? I will take theta here, phi here. Suppose I will take a phi here. This will be my the small element I want. So this will be d phi, right? And this is the length I want here, dl. Suppose I want this element dl. So how do I find this element? So dl is equal to r times d phi, because this is the length of a sector, right? dl is equal to r times radius times the angle. So this is the angle here, d phi, so it is radius times d phi. So this is the dl element here, r times d phi. And how do I travel the segment? I travel the segment from 0 to the angle. Now 0 to 180 degree will be here. So it depends. If this was a half, then it will be 0 to 90 degrees. Okay. So dl it will be r times d phi here. So I got my dx here. So it is dq is equal to lambda times r times d phi. So if there was a ring, this would have been the length. Got it? Now these are all type of linear objects like a rod, ring. Now there are things, right? There are three things. Okay, there is lambda, there is sigma, and there is rho. So lambda is generally used for rods, rings, where you need to take a length. It will solve your problem, like length you travel. Sigma is generally, so it is mass per unit length or charge per unit length. If you have to sigma is generally comes in cases of disk. So disk, what will happen, you won't be able to take length, right? You have to take the area here in all these cases. So what is sigma? Sigma is equal to mass per unit area, charge per unit area. So in all such cases, wherever you think you have to travel as a area, sigma will come into picture, and rho. If there is a sphere, so sphere, if you consider like a uh, earth, you have to travel it, right? It's a three-dimensional proper figure. So here volume will come into picture, right? Rho is equal to mass upon volume, charge upon volume. So you need to understand it, where when sigma will come, when lambda will come, and when rho will come. These are fundamentals. Now let's suppose there is a disk, right? Now suppose there is a disk. So how do I solve for a disk? What I do? Now I, in a disk, I take a smaller disk, because I will travel it disk wise, right? I will travel it like this, like this, like this, and I will cover the entire disk. So I take this disk, suppose. So what I will do is I will draw this. I'll take a small disk here. Okay, this is my radius r of this disk. Okay, so what I will do here is, you can understand, if I take this disk, okay, and I take a knife and I cut this disk, suppose, what will happen? The disk will look to me as like this. So what is the length of this disk? It is 2 pi r, right? Because it's a circle, and here it is dr. Suppose dr is the width of it. I take the width of it as dr. So here this is dr. So what is my area of the rectangle? It is 2 pi r dr. You are able to understand this, right? So this is a disk with a distance from center is r. The thickness of it is dr. So just imagine this is a circular thing. I cut the ring, I cut the disk actually, and I make it a rectangle 2 pi r dr. If you are not able to understand it, you can do it by area also. The area of outer circle minus area of inner circle, it will be pi r plus dr square minus pi r square. This also works. This will also give you. Okay. So yeah, this is for a disk. For sphere, you have to do it similarly. For sphere, now if there is a sphere here, sphere you have to take it volume wise. So how will you do it? So we know that, just imagine the same way, okay? So what will be the surface area? Here the, it is surface area into the thickness will give us the volume, right? So what is the surface area of a sphere? Surface area of a sphere is 4 pi r square into the thickness. Thickness is dr. Thickness will be the same, dr. So it is dv is equal to 4 pi r square dr. So you are able to get the small volume partition of it. Here you are able to get the small area partition of it. So this will be your dA, this will be your dV. Okay. So what is it? So finally, to say it's lambda is equal to dm by dl. What is sigma? Sigma is equal to dm by dA. And what is rho? Rho is equal to dm by dv. This dm can also be dq or anything. Okay. So how, what we finally do is, we say dm is equal to lambda is equal to dl. Dm is equal to sigma times dA. dv is equal to dm here is equal to rho times dv. So in our formulas we place this going ahead. So finally, what is important? Understanding what is, how to find out dv, how to find out dA, how to find out dl. That is very important. And there could be actually different type of questions which can be formed around disk and all. Like this will not always be the same. This can change. Understanding this is very important. Like how we are going, how we are traversing the length of it, like a to a plus l. How we are taking the angle, like theta, del, theta. How we are reaching out to this formula. That is very important. Okay. Now just to be little careful here, I will explain you scalars. There are scalars and there are vectors, right? So generally when we do things around other things like moment of inertia, center of mass, those are all scalars. So we don't have to take the components into action. Like if you just integrate, you will get the answer. But in case of vectors like force, if suppose there is some ring here, okay, and you need to find out the force of this charge on this part, how there will be angles here, like this will give around force like this. So it will be here, there will be two angles, right? F cos theta will be there, F sin theta will be there. So this will be F cos phi, this will be F sin phi. So you need to find both of this, Fx, and you have to find Fy, right? Yeah, so wherever there are vectors, we need to find both sin phi and cos phi. So this is it for integration. Hopefully this has been helpful to you. Please like and subscribe. You can reach out to me over mails if you want to understand some specific concepts or some specific questions which you have, which you would like me to solve. Hopefully this will be helpful.